Hi friends, today I am giving a lecture on AVL tree rotations. That means what are the types of rotations we have to use in AVL tree that we have to discuss in this video. In the previous video, we are discussing about what is AVL tree, why we are going for AVL tree. Next, what is rotation and what are the why we are go for rotations and what is balance factor and what are the valid balance factors in AVL tree. So these are the points that can be discussed with one example. Now in this video, we go for what are the types of rotations used in AVL tree. Mainly, rotations are used for converting larger height of a tree into smaller height of a tree. So for that purpose, we have to use rotations. So there are generally four types of rotations are there. First one is LL rotation, that means left rotation. Second one is LR rotation, that is left right rotation. Third one is RR rotation, that is right rotation. And fourth one is RL rotation, that is right left rotations. Okay, so these rotations can be performed by considering the balance factors -1, 0, 1. Okay, balance factor of a node is equal to height of a left subtree minus height of a right subtree. Okay, now the rotations can be performed only on 3 nodes. Okay, how we are performing the rotations on these 3 nodes, so that we are discussed. So first rotation is LL rotation. Okay, so initially we are getting this binary search tree. In that binary search tree, there are 2 vertices are there. So here first one is node 30. This is the root node. Okay, now I want to insert element 20 in that existing tree. So 20 is compared with 30. 20 is less than 30. Now 20 can be inserted at the left hand side of node 30. Okay, now what is the balance factor of 20? Height of left subtree is 0. Height of right subtree is 0. That means there is no left subtree and there is no right subtree. So that 0 minus 0 is equal to 0. Now, what is the balance factor of 30? So here left hand side only one edge is there. Height is equal to 1. Right hand side there is no edges are there. So that is 0. Height of the left subtree is 1. Height of the right subtree is 0. Therefore, 1 minus 0 is equal to 1. So these 2 nodes balance factors are valid because here 1, here 0. So 1 and 0 are the valid balance factors. Now in this, for this tree, we have to insert node 10. Okay, first node 10 can be compared with 30. So 10 is less than 30. Go to the left subtree. In the left subtree, node 20 is there. 10 is compared with 20. 10 is less than 20. Then go to the left subtree. It is a empty node. Now we are inserting node 10 in that empty node. Okay. Now here 10 can be inserted at left. Okay. Left of 30 and go to left of 20. 10 is inserted. So this is the left subtree and this is also a left subtree. Okay. So because of that reason, we can say that this is a LL rotation. Okay. Node 10 can be inserted at left of left. Okay. So this is first left and this is second left. Left of left. Okay. Hence we can say that this is this rotation is called as a LL rotation. Okay, node 10 can be inserted at left of 30 and left of 20. Okay, hence this name is LL rotation. Now observe the balance factors after inserting 10. Okay, first 10 balance factor, height of the left subtree is 0, height of the right subtree is 0. 0 minus 0 is 0. Next, 20 balance factor. Height of the left subtree is 1. Height of the right subtree 0. 1 minus 0 is equal to 1. Next, 30 balance factor. Height of the left subtree is 1, 2. That is 2 minus height of the right subtree is 0. 2 minus 0 is equal to 2. Here 0 is a valid balance factor. 1 is a valid balance factor. But here 2 is there. 2 is not a valid balance factor. Okay. Now, here height of the tree is 2. Okay. To convert this larger height of the tree into smaller height of the tree, we have to perform the rotation with respect to node 30, because at node 30 we are getting the imbalance. Okay. What is imbalance? Balance other than minus 1, 0, plus 1. Any number is there, that number is called as imbalance factor. Here imbalance factor is 2. Okay. Now we are performing, here left is there. We are performing right rotation with respect to the node 30. Okay. So now after performing a right rotation, 30 can be goes to down, 20 can be goes to this place, 10 can goes to this place. Okay. 30 can be goes to this place, 20 can be goes to this place, 10 can goes to this place. Okay. So this is the AVL tree we are getting after performing LL rotation. Okay. LL rotation. So now observe the balance factor. So 10 balance factor. There is no left subtree. There is no right subtree. 0 minus 0 is equal to 0. 30 balance factor. There is no left subtree. There is no right subtree. So 0 minus 0 is equal to 0. 20 balance factor. Height of the left subtree is 1. Height of the right subtree is 1. 1 minus 1 is equal to 0. So all balance factors are valid balance factor. This is the AVL tree. Okay. This is a height balanced binary search tree. This can be treated as AVL tree. Okay. So here what rotation we have to perform? We are at left of left. Okay. At this point we are getting the LL imbalance. LL imbalance. Now we have to perform the right rotation. Okay. Whenever right rotation is performed, 30 goes to down, 20 goes to root node, and 10 goes to 20 node place. So this is the tree we are getting. Okay. How many number of rotations we have to perform? Only one rotation. So LL rotation requires single rotation. Okay. So here rotation can be performed only on 3 nodes. 30, 20, 10 rotation can be performed on 3 nodes. Next one, second rotation is LR rotation. Okay. So in the LR rotation, initially this tree is there. 30 is the root node. Okay. Next 10 can be inserted. So 10 is compared to 30. 10 is less than 30. So 10 can be inserted at the left subtree of 30. So 10 is inserted. What is the balance factor of 10? So there is no left subtree of 10. There is no right subtree of 10. So height of left subtree is 0. Height of right subtree is 0. 0 minus 0 is equal to 0. Now 30. 30 balance factor. Height of the left subtree is 1. Height of the right subtree? No. There is no right subtree. So that is 1 minus 0 is equal to 1. Both are valid balance factors. Okay. Now, in this tree, we want to insert 20. 20 can be inserted. Okay. For inserting 20, first 20 is compared with 30. So 20 is less than 30. So go to the left. So this is the first left. Go to the first left. Next one, 20 is compared with 10. So 20 is greater than 10. So go to the right. So go to the right. 20 can be inserted at right subtree of node 10. So this is L and this is R. Then we are getting LR rotation. Okay. Insert 10 insert 10 at left and then insert 20 at right. Insert 10 at left hand side of node 30 and insert 20 at right hand side of 10. Okay, so we get LR imbalance. What is LR imbalance? After inserting 20, okay, now observe the balance factors. Here 20 balance factor, there is no left subtree, there is no right subtree, 0 minus 0 is equal to 0. Next 10 balance factor, height of left subtree 0, height of right subtree 1, 0 minus 1 that is equal to minus 1. Next 30 balance factor, height of left subtree is 2 minus height of right subtree is 0. 2 minus 0 is equal to 2. Okay, now we are getting imbalance factor. Imbalance factor 2 is not there in the balance factor. We are getting imbalance at this node. Okay, now this rotation is called as this is called as LR imbalance. Imbalance can be occurred at this position, so that is LR imbalance. Okay, insert 20 at left hand side, insert 10 is left hand side of 30, insert 20 at the right hand side of 10. So here LR, here we are getting balance factor 0, here balance factor minus 1, here balance factor 2. 2 is a imbalance. So after inserting 20, so go to left and go to right, then we are getting the imbalance. Then it is called as a LR imbalance. Okay, next. So to convert this imbalance, LR imbalance, we have to use a rotation. That rotation is called as LR rotation. LR rotation. Okay. Now, in the LR rotation, first we have to perform R rotation. After that, we perform L rotation. Okay. Now, so first we have to perform rotation with respect to the node 10. Okay. So this rotation is here. 20 can be inserted at the right hand side of 10. Okay, here right is there. Now we have to perform rotation with respect to the left. Okay, with respect to the left at node 10. Okay, after performing left rotation, 20 goes to this position and 10 goes to this position. 20 goes to this position, 10 goes to this position. So now 30 here replace, 20 goes to this place and 10 goes to this place. So this is the tree we are getting after performing left rotation. Okay, now check the balance factor. Here 0, here 1, here 2. Okay, so one rotation is completed. Next we have to do another rotation because here the balance factor is 2 we are getting. Okay. Now this is L is there. Now we have to perform right rotation. Okay, imbalance is occurred at with respect to the node 30. Now we have to perform right rotation by considering the node 10. So after performing right rotation, 30 goes to down, 20 goes to top, 10 goes to 20th place. So 20 goes to top, 30 goes to right of 20, 10 goes to this place. So now balance factors 0, 0, 0. So this is the height balanced binary search tree that is called as AVL tree. So this AVL tree we are getting after performing LR rotation. LR rotation. So here we are performing left rotation. Here we are performing right rotation. This is L and this is R. This is called as LR rotation. So left rotation is L, right rotation is R. So we are getting LR rotation. Okay. First we have to perform at which point node is inserted. At that point we have to perform the rotation. Here 20 is inserted at this position, so that we have to perform rotation first at this point. Okay, at this point. After that we have to perform where the imbalance is occurred. Okay. So this is called as Euler rotation. Okay, you have one doubt. Okay, here first we have to perform in this place rotation or in this place. Confusion. Okay, so simply simple condition is, okay, here first node 30 is there, next 10 is inserted, after that 20 is inserted. Okay, last element 20 is inserted. Okay, now at this position we have to perform a rotation first, after that perform rotation displace. Okay, this is the simple trick we have to follow. Okay, now any rotations we have to follow. Okay, the middle node, the middle node becomes the root node. The middle node becomes the root node. Okay, here middle node is 20, 20 becomes the root node. Okay, this is the description about Euler rotation. Then you go for RR rotation. Next, the third rotation, RR rotation. RR means right rotation. Okay, first this is the initial tree. First here root node is 10 is inserted. After that we have to insert 20. So 20 is compared with 10. 20 is greater than 10. So 20 is inserted at the right child of 10. Now the balance factors. So 20 does not have any right subtree and left subtree. So that is 0 minus 0. That is equal to 0. Here 10 balance factor is, there is no left subtree. That is 0. Right subtree contains one edge. That is 0 minus 1. So 0 minus 1, that is equal to minus 1. Here 0 minus 0 is equal to 0. So minus 1 and 0 are the valid balance factors. Now insert 30. Okay, so in this tree we have to insert 30. First 30 is compared with 10. So 30 is greater than 10. Go to the right subtree. Here 20 is there. 30 is compared with 20. 30 is greater than 20. So go to the right subtree. The right subtree is empty. So now we have to create a node and insert value 30 into that node. Now 30 is inserted, 10 right and 20 right. 10 right child and 20 right child, we are getting insert 30. Insert 30 at right of right. Right of right means right of 10 and right of 20 we are getting in 30. So 30 is inserted, 10 right child, 20 right child is 30. So this is R and R. Okay, so here we are getting RR rotation. Here by inserting 30, so the tree becomes imbalanced at this point. Okay, now balance factors. 30 does not have any left child and right child. So 0 minus 0 is equal to 0. For node 20, there is no left subtree. So that is 0. 0 minus right subtree height is 1. 0 minus 1. So here 0 minus 1 is equal to minus 1. Next one. For node 10, so there is no left subtree. So that is 0 minus right subtree height 1, 2. So 0 minus 2 is equal to minus 2. Okay. So in this way we are getting the balance factors. Here the balance factor is 0. Here the balance factor is minus 1. Here the balance factor is minus 2. 0 minus 1 are valid, but minus 2 is not valid, because valid balance factors are minus 1, 0, plus 1. So we are getting RR imbalance. So this imbalance is called as RR imbalance. By inserting 30 at right of 10 and right of 20, right of 20. So then we are getting the tree becomes imbalance. So that is called as RR imbalance. Okay. So whenever imbalance is occurred at this point, now here RR is there. Now we have to perform left rotation, because the two nodes are inserted at the right hand side of right hand side, so that we have to perform left rotation. So with respect to the node 10, because at node 10 we are getting the imbalance, so that we have to perform the left rotation with respect to the node 10. After performing left rotation, this node 10 can be down and 20 goes to top and 30 goes to this place. So here 20 goes to this one, 20 becomes the root node, 10 goes to down, 20 left child is 10 and 30 goes to this place, 20 right child is 30. Okay, so the balance factor, so there is no left subtree, there is no right subtree, 0 minus 0 is 0. Here there is no left subtree, there is no right subtree. Height of left subtree is 0, height of right subtree is 0, 0 minus 0, 0. Here height of left subtree is 1, height of right subtree is 1, 1 minus 1, that is equal to 0. So after performing RR rotation, we are getting the final AVL tree. Okay. So how many number of rotations we have to perform? Only one rotation. So RR rotation requires a single rotation. At which point we are getting the imbalance factor, at that node we have to perform the rotation. Okay. Next one. Go for fourth one. Fourth rotation is RL rotation. RL rotation means right left rotation. Okay. Initially tree is this one. First node 10 is there. So then we want to insert node 30. So 30 is compared with 10. So 30 is inserted at the right hand side, right child of node 10. Okay. Now what is the balance factor? There is no left subtree of 30. There is no right subtree of 30. So 0 minus 0 is 0. Next, here balance factor for 10 is there is no left subtree for 10. So that is 0 minus height of right subtree is 1h, that is 1. 0 minus 1, that is equal to minus 1. Okay, 0 minus 1 is equal to minus 1. 0 minus 0, that is equal to 0. Now 30 is inserted at the right hand side of 10. Now I want to insert 20. So 20 is compared with 10. It is greater than 10. Go to the right subtree. In the right subtree, node 30 is there. 20 is compared with 30. So 20 is less than 20. So less than 30. Then go to the left subtree. So 20 is inserted at the left hand side of node 30. So 20 is inserted at the left hand side of 30. 30 is inserted at the right hand side of 10. Okay. Now we are getting the RL imbalance. Okay. 30 is inserted at the right hand side of 10. So that is R. Next, 20 is inserted at the left hand side of 30. So that is L. RL rotation. Okay. So we are getting imbalance first. We are getting imbalance here because node 20 has balance factor 0, because height of left subtree 0, height of right subtree 0, 0 minus 0 is 0. Here 30 balance factor, height of left subtree is 1h, that is 1. There is no right subtree, so 1 minus 0. So 1 minus 0 is 1. Next, height of here node 10 balance factor, there is no left subtree, so 0. The height of right subtree 1, 2. Two edges are there. So that is 0 minus 2. That is equal to minus 2. Okay. The balance factor is minus 2. But it is an invalid balance factor. So valid balance factors are minus 1, 0, plus 1. It is an invalid balance factor by inserting 20 at the right hand side, left hand side of 30 and the right hand side of 10. Okay. So this is called as RL imbalance. RL, we are getting the tree imbalance, that is called as RL imbalance. Whenever RL imbalance is occurred, we have to perform two rotations. First one is R rotation and second one is L rotation. Okay. Now we have to perform at which place rotation or this place rotation. First we have to perform rotation at this place and this place. Okay. So node 20 is inserted last. node 20 is inserted last in this tree. So first we have to perform in this place rotation. Here this is the L is there. Now we have to perform R rotation, opposite rotation. Here L is there, we have to perform right rotation. When we are performing right rotation, so 20 goes to this place and 30 goes to down. Okay, so this is the tree we are getting after performing. Okay, first we have to perform in this place rotation. Okay, because at last node 20 is inserted. Okay, so before 20, 30 is inserted. At last 20 is inserted. Now we have to perform in this place rotation. Here this is the left is there. Now we have to perform the right rotation. So now 20 goes to this place and 30 goes to this place. 10 is there. Again we are getting the imbalance. Okay, here at this place we are getting the imbalance -2. Now here this is R and this is R. Now we have to perform left rotation. At which point at this node we have to get the imbalance, so that we have to perform the left rotation. Okay, so after performing the left rotation we are getting this tree. So 20 goes to this place, 10 goes to this place, 30 goes to this place, 30 goes to this place, 20 goes to this place, 10 goes to down, because we are performing the left rotation. So after performing this one, 20 is the root node, 10 is the left child of 20. So balance factor, there is no left subtree, there is no right subtree. 0 minus 0. So 0 minus 0 is equal to 0. There is no left subtree, there is no right subtree. 0 minus 0 is equal to 0. Here left subtree height value 1 minus right subtree height value is 1. So 1 minus 1 is equal to 0. Okay, here this is a RL rotation. Okay, we have to perform two rotations. First perform right rotation. After that we perform left rotation. First we have to perform right rotation. After that we have to perform left rotation. Okay, so first right rotation can be performed at which point? At which point the last node is inserted. At that point we have to perform first right rotation. Whatever the resultant tree we are getting, on that one we have to perform the left rotation. The same procedure is also followed in LR rotation. Okay, first we have to perform left rotation. After that we have to perform right rotation in the case of LR rotation. Okay, so in RL rotation we have to perform two rotations. First one is right rotation and second one is left rotation. Okay, in the case of LR rotation also, first we have to perform left rotation. After that we have to perform right rotation on the resultant tree. So both LR and RL rotations require two rotations, that is double rotations we have to perform. LR and RL rotations, whereas LL and RR rotations requires only a single rotation. Okay, here RR is there. Okay, so opposite is L, so we have to perform left rotation. Here LL is there, opposite is R, so we have to perform right rotation. LL and RR requires single rotation. LR and RL rotations requires two double rotations. Okay, so at which point rotations can be performed on only three nodes. The middle node always becomes the root node. Okay, at final the middle node becomes the right node. Okay, this is the description about rotations used in AVL trees. Thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasa.